We are on page 5. The example towards the top says, according to the U.S. National Center for Health Statistics, 0.15% of deaths in the U.S. are 25 to 34-year-old whose cause of death is cancer. In addition, 1.71% of all of those who die are 25 to 34 years old. What is the probability that a randomly selected death is the result of cancer if the individual is known to have been 25 to 34 years old? So we have the word is known, and that's just like given. And so for this problem, it's asking to find the probability that a randomly selected death is the result of cancer, given they are for an age between 25 and 34 years old. So from this, we have to look at the total of, in the numerator, it's going to be the probability of having cancer and being 25 to 34 years old using our formula. And that is going to work out to being, if you look at the numbers that we were given, 0.15% of deaths in the U.S. are 25 to 34 years old whose cause of death is cancer. So that would be our connective there, and I'm going to write this as a decimal, so it's 0.0015. And then the denominator is what is given. And in this case, it's 25 to 34 years old. And the probability that they have died when they are 25 to 34 years old is also given to us. That's 1.71% of all those who die are 25 to 34 years old. So we're writing that as a decimal. We have 0.0171. And then dividing these out, rounding 4 decimal places, we get 0.0877. Right below this is multiplication rule, which says that the probability of events A and B, both occurring, is going to be the probability of A and B is going to be the probability of A times the probability of B given A. We have independent and dependent events. Determine whether the events E and F are independent or dependent and justify your answer. Again, independent would be that one probability of one event affects no way the other event, where dependent one would affect the outcome of the other. So the first one that we have here says determine whether the events E and F are independent or dependent and justify your answer. So we have speeding tickets on the freeway and being pulled over by a police officer. We will say that those are dependent. Most likely you were pulled over by that police officer because you were speeding. B says you get a high score on the statistics exam and the Dodgers win a baseball game. Unfortunately, those are independent and they do not have one, does not affect the other as much as we would like it to. The next thing that we have is multiplication rule for independent events. So if you have independent events, then the probability of A and B is just going to be the probability of A times the probability of B. The next example that we have says, according to the National Vital Statistics Report, 20.1% of all pregnancies results in a weight gain of excess of 40 pounds for singleton births. In addition, 49.5% of all pregnancies result in the birth of a baby girl. Assume gender and weight gain are independent. So they flat out tell us that they're independent. What is the probability that the randomly selected pregnancy results in a girl and a weight gain in excess of 40 pounds? So this is the probability of having a girl and a weight gain, and I'll put WG for weight gain and G for girl, in excess of 40 pounds. And since these are independent, we can use the formula that's up above, which is just going to be the probability of having a girl times the probability of having a weight gain in excess of 40 pounds. And so looking at our problem in here, it does say that 49.5% of all pregnancies result in the birth of a baby girl. So we're writing this as a decimal. We have 0.495. And the probability of having a weight gain in excess of 40 pounds was also given to us. And that's going to be the 20.1%. I'm writing that as a decimal. And with these two values, we will multiply these. Writing 4 decimal places, which is what we normally do for probabilities, we get 0.0995. So if you have any questions, definitely let me know.